this. So we'll take care of homework tomorrow. Taking care of some more notes right now. Some of these should be things that you already know, or at least are very, very pretty straightforward or obvious for you. Addition, property of equality. If you take two things that are equal and add the same thing to both sides, right, they stay equal. Yes. This is still 2-4, yes. What? Again, that's up to you. I believe that some of these things you should already know, like addition property is adding the same thing to both sides of an equation. The subtraction property of equality says that you can subtract the same thing from both sides of an equation. Multiplication property of equality says that you can multiply the same thing to both sides of the equation. And division property says that you can divide the same thing as long as it's not 0 to the both sides of the equation. Right? Usually this is going to show up more like if you had x minus 4 equals 8, right? How do you solve? You add 4 to both sides and get x equals 12. That is the addition property of equality, right? If instead you had x plus 4 equals 8, you would subtract 4 from both sides and get x is 4. That would be the subtraction property of equality. Again, these 4 properties are properties you use basically all the time as you're solving algebraic equations, right? None of these should be new. All right. Some more properties. Reflexive property of equality. Reflexive property of equality says that something is equal to itself. Symmetric property says that if A equals B, then B equals A. This one you're going to see more often as like, what, 4 equals X, and instead you say X equals 4, right? Where it's not the exact same thing, they're just equivalent things, you can switch them, right? Reflexive is the exact same thing on both sides. Yep. Transitive property. If A equals B and B equals C, then A equals C. Transitive property kind of similar to our law of syllogism, right? Where there's the same thing happening and you're kind of just pushing the two statements together. So B is definitely equal to itself, right? So all it's saying here is that if something is equal to something else, right, and that something else is equal to something else, then the first and the last thing have to be equal to each other, right, whatever they are. Substitution just says if two things are equal, then one can be substituted and replaced for the other, right? If you want a sports analogy here, it's no different than like a basketball game. If you get substituted in or out of the game, right? Generally speaking, you're being substituted with someone equivalent in some way, right? Not always, but yeah, yes. This would most likely be in like, we've done this a number of times this year. If we had like y equals 3x plus 4, and we knew that x is 7, right? This just says we can plug in 7 for x. Right? Distributive property, right? Just says that we're distributing that value to the other values, right? So we get AB plus AC. Any questions over the properties here? All right. State the property that justifies the statement. If 80 equals the measure of angle A, then the measure of angle A equals 80. This is the symmetric property. If RS equals TU and TU equals YP, then RS equals YP. This is the transitive property. Right, again, you're noticing the same thing happening exact on the sides there. It's just like pushing them together. I'll be honest, questions like number 3 come across as a little awkward when you're first looking at them. So the question that you really should be asking yourself is, what do you have to do to go from the hypothesis to the conclusion? No. You are using division, right? The division property of equality says you can divide. What are you doing to go from here to here? You are dividing both sides by 7, right? If it were the other way, right? If this were if x equals 4, then 7x equals 28. You might be able to say that's substitution. Otherwise, you would probably say that it is multiplication, right? There, you might be able to get away with one or the other. If VR plus TY equals EN plus TY, then VR equals EN. No. So what's changing from the first statement, the hypothesis, to the conclusion? The TYs are getting taken out, right? You are subtracting it from both sides. All right. You can do some shortening of words here. I am a little bit particular on subtraction. You cannot shorten subtraction to SUB because it might also be substitution. And if I had never had a student that honestly mixed those two things up, then it would probably be okay. But I know for pretty sure that I've had students that literally put SUB and meant substitution here, not subtraction. I don't know how, but they did it, right? Property of equality. And it's POE because mathematicians are lazy and we shorten stuff when we can. SUBT would be fine, right? Division, DIV would be fine, right? Again, I'm just telling you that it would not be clear if you only put SUB for substitution or subtraction. If the measure of angle 1 is 30 and the measure of angle 1 equals the measure of angle 2, then the measure of angle 2 is 30. Yes? Transitive. I am okay with transitive. Otherwise, here I would also be okay with, no. Here I would also be okay with substitution, right? Transitive and substitution have a weird relationship. There are definitely times that you cannot say transitive when it's substitution. Those are very, very clear. So you have 3x plus 8 equals something, and you know x is 4, right? It's substitution. You can't say it's transitive. On the other hand, transitive and substitution, when it's just things like this, can be a little bit more difficult. Usually, I'm a little less particular on it unless it's very, very clear. To me, this is very clear it's transitive, right? It's in the correct order. It's set up to be exactly what it says it is. There, you have to pretty much say transitive. Here, if you said transitive or substitution, I'd be okay. All right? And you could probably make a case anytime it's transitive for substitution, but you'd probably have to argue it with me a little bit. Like I said, the other way does not work as well. Write a 2-column proof to prove each of the following. So we want to prove that if we have the equation 8x minus 5 equals 2x plus 1, we want to prove that x equals 1. So we're setting up a 2-column proof. This is probably or possibly the first time you have ever done a 2-column proof. When you are writing this in your notes from what we looked at yesterday, you should start with writing your given. So you write given 8x minus 5 equals 2x plus 1. Underneath it, you write prove x equals 1. So every time we write a proof, you will always write the given. You will always write what you are trying to prove first. In a 2-column proof, you will then make 2 columns. Surprise. One of the columns will be named statements, and one of them will be named reasons. So you're going to state things, and then you're going to give why they are true. In a very general basis, this is not exactly 100% true, but it's nearly 100% true, at least very, very close to 100% true for your classes or the proofs that we're going to do this year. Your first step is nearly always the same thing. Not literally the same thing, but your reason will be the same thing. Your first step will always be to state your given. Which is 8x minus 5 equals 2x plus 1. All right, does that mean that you didn't have to write it here? No, I told you have to write it here as well. All right, you can be angry that it feels redundant to have to write it twice, very, very close to each other. You can come in and have an argument with me about it if you want to, but you have to do it. You just have to do it. All right, so almost always, this given or givens, if there's more than one, will be the first statement or the first couple of statements that we make. So if you ever come in for help on a proof and you don't have your given, what you're trying to prove, your 2-column proof setup, and your first step done, I am likely to not be too encouraged to help you go further, right? So you can't walk in and say, I didn't know how to do this proof and not have anything on the page. Minimally up until this point, and one more thing, you should have every single time you do a proof. If you don't know what to do after that, I can help you. If you can't set it up to here, which is just the standard way, then we have other issues, right? That's more of a not trying than not knowing, right? I said there's one more thing that you should always have, and that is your reason for this. How do we know that 8x minus 5 is 2x plus 1? It is given. Your first step is nearly always going to be given. If it came from where it says given, then yes. Then yes, it will be given. I didn't really say, this is starting with a proof called an algebraic proof. The reason we start with algebraic proofs is because theoretically you should be able to do everything in the statements column without help, right? So how would you solve for x? You might subtract 2x from both sides, and what would you get? 6x minus 5 is 1, right? You do not need to show, like we would usually write minus 2x under each, you do not need to show that that is not a step, right? You don't have to show it, you can just write what your next step is. Given this statement, how do we know this one must be true? The subtraction property of equality says that we are allowed in any equation to subtract the same thing from both sides, and we subtracted 2x from both sides. I prefer POE to just prop. You could do prop and then an equal sign. There is addition and subtraction by itself, which is the problem. So like if you're doing it on one side by itself, you might call it just subtraction. So like if on one side I had, if it was 8x minus 5 plus 3, right? You might just do addition, right? So I like POE. That's kind of where I've come to. I think I got that from a student who also just wanted to use shorthand. Before that, I always used prop equal sign, right? Mahi? Yes, so we could have added 5 to both sides in that step, right? Or it's what we're going to do now. And what would our next step look like? 6x equals 6. What did we do to both sides to get here? The addition property of equality, I suppose. What? We should be able to remember addition, multiplication, subtraction, and division. I don't know if I did that in the right, definitely not the right order, but those four should be, it's just what they are, right? Step four, we get x equals 1. And that is the division property of equality because we divided 6 to both sides, right? We are done because our statement is exactly what we were trying to prove, right? So that's how you know you're done in a proof, is if if the last statement you make is the same as the statement you were trying to prove, then you're done. Then you would find that your statement literally is something else. So like if we got x equals 2, and that was the only possible answer, then it can't also be x equals 1. And then we would, it doesn't really happen that much in what we do. It does happen in real life. In which case you would just say that that your statement is false, right? Technically when we have this, and we kind of saw this before, and this might be a good time, what we're really saying is if 8x minus 5 is 2x plus 1, then x is 1, right? That's what we're saying. And so really we're proving a conditional statement to be true. And sometimes you will see it written this way, like it'll just say, write a proof for if 8x minus 5, this is what it's saying to do. Good. Other questions there? All right, writing a 2-column proof. Eight minus 3x over 4 is 32. With algebraic proofs, in the worst case scenario, right, we should be able to at least go down and list all of our statements. Right, so we should be able to solve for x for this problem since at least last year algebra class, right? If not the year before in pre-algebra, if that's the class that we took. So again, you start by writing your given and what you're trying to prove. Then we make our 2 columns. Now the book will sometimes use alphabetical instead of numerical. I like numerical. It's pretty much the only thing you'll ever see me use unless I'm writing one from the book. So I almost always start with 1. Again, the book will sometimes go that as a lowercase a instead. And again, our first statement, 8 minus 3x over 4 is 32. How do we know that? Because it was given to us, right? Yeah, what's the next step? Good. And what would we get? 128. Good. Multiplication. POE, property of equality. All right. What did we do to both sides, or what were we supposed to be doing to both sides, right? We were supposed to be multiplying by 4, right? Sure. There is nothing wrong with adding 3x to both sides. It is probably not what I would do here. Probably subtract 8 from both sides. We're left with negative. Again, you cannot just use SUB letters, SUB. However, you can use SUBT for subtraction. Subtraction property of equality, we subtracted 8 to both sides. Divide both sides by -3, and we get -40. The reason, good.
He's gonna make them harder if you keep saying they're easy.
No, they mostly do what they do. I'm not going to purposely make them harder. Questions on this one? I think we have one more that we have to look at here. No, this one's more interesting. We'll do this one. Given C equals 5/9 F minus 32, F equals 9/5 C plus 32. There's 2 letters. This is how we convert Celsius to Fahrenheit and Fahrenheit to Celsius, because some countries refuse to give up Fahrenheit as their standard practice. There might be more countries that use Fahrenheit than at least the metric system, but pretty much anywhere you go, they will give their weather in Celsius. This one, at least, I think you can make an argument for Fahrenheit that it's a little bit more precise, I think, because it expands more. Like if you say 35 degrees Celsius versus like its comparative degree in Fahrenheit, the Fahrenheit degree is going to be closer to what it actually is, because Fahrenheit's a little bit more spread out than, but otherwise there's not really a good reason to be different than everybody else. All right, again, first step. Like you just don't know how to get out of it?
Yeah, oh. I don't know what to do. I don't even know how I got there.
You just quit out of it. All right. All right. So we do have choices here. We do have choices here. What might we do in step 2? You could multiply by 9. You could distribute the 5/9. You could divide by 5/9 or multiply by 9/5, right? I think those are our 4 choices. I think some of them are better choices than others, right? So who thinks distributing here is the best choice? Distribute the 5/9 to the f and the -32. All right, that might be what you would do. It is probably not the best choice, right? So once you hear the 4 choices, right, other ones should stick out to you as better. A second choice was to divide by 5/9. So you can divide by 5/9, but what does dividing by 5/9 look like? Yeah, so multiplying by 9/5 is probably better than dividing by 5/9, right? What? Yeah, yeah, they are. But again, the problem is dividing by 5/9 to the c, right? What does that actually look like? The multiplying is probably easier. So here, I would probably go with multiplying by 9/5, right? So you could multiply by 9, but your next step would be divide by 5, right? So why not do them in the same step? It's just a fraction. So multiplying both sides by 9/5, we get 9, that's a 9, not an A. 9/5 C equals, well, if we multiply 5/9 by 9/5, we get 1/1. So we're left with F minus 32. So again, you could technically call it division, right? That you divided out the 5/9 and then you divided the C by 5/9. I would think you'd need one more step to do that well on the left-hand side. So I would call this multiplication, that you multiplied both sides by 9/5, I think is cleaner. Would I mark it wrong if you called it division? I might. You would need to come and argue with me about it. Argue doesn't mean like we're gonna actually sit there and like have a fight. It's just like you need to prove your point that like what you're saying is true as well. What would we do next? If we multiply by 5, we'd be going backwards, but I agree with the adding 32 to both sides. What do we get if we add 32 to both sides? Nine-fifths C plus 32 equals F. What property did we use? Is this what we are trying to prove? No, it is very, very, very close, right? But to be done, it has to look exactly like this. The symmetric property of equality, where we are just switching what's on each side of the equal sign. I'm in the wrong class. Your homework assignment for tonight. Oh, I don't need to look it up here. I know what it is. Well, let's see. Page 151, 1 to 19. 151, numbers 1 to 19. Excuse me, I'm talking. You will notice that this is a review assignment because we will be having a quiz over 1-1 to 1-4 tomorrow. The 1-4 part of the quiz will only relate to properties and postulates and stuff that we covered in it, not an actual proof. So there will need no actual proof, but the properties can be there, but it's going to be mostly over the stuff from 1-1 to 1-3. Yes. No. What? What postulate don't you know? Okay, you have 24 hours. And your clock started 30 minutes ago. What? Which properties don't you know? Yeah. For the most part, the properties we went over today, you might need to spend a moment on reflexive and symmetric just to keep them straight, and 30 seconds on transitive. But you should know distributive, addition, subtraction, multiplication, and division, right? The postulates, there were 7 of them. 2 of them related to a line having 2 points. 2 of them related to a plane having 3 points. 1 of them was if 2 points are on a plane, then the line containing them is in the plane. And then, yeah, the other 2 was intersections of lines is a point, and intersection of planes is a line. All right, I need to stop